So today I'm going to be showing off my simple emotion detection program. First I'm going to play this video and do a little bit of commentary, and then I'll briefly explain how I got it to work. So starting the video now, first you can see I have no expression on my face, so the computer reads that properly. Then I give a little bit of a smile, it reads happy. I change to a surprise expression, and immediately it switches to that. Kind of go to like a sad expression, a little bit of a frown. Go to an angry expression here. Obviously with the eyebrows furrowed, looks angry. Back to happy here. Back to surprise. I kind of cycle through some emotions in this video just to see if it's working properly. I think one of the biggest problems I had when programming this was getting it to tell the difference between my normal expression and my sad expression, as you can kind of see at the end there, or maybe sometimes when I'm switching emotions, if I just drop to a normal expression, try not have a face on, it'll default to sad. That was kind of one of the struggles I had with it, and I'll talk about why in the code here. So if you look at it, mostly pretty standard. I use this like an example of this guy's code, Matthew Earl, on GitHub. I was referred to him by somebody named Rajiv Ratan. He does a lot of videos like on YouTube and stuff. And when I was like first learning OpenCV, I got a lot of the learning done through him. Now, this Matthew Earl guy, he did something kind of interesting. He used a program for face swapping with Python, dlib, and OpenCV, and he used this paper. He got this algorithm described from this paper called 1 millisecond face alignment with an ensemble of regression trees. I think it was published in Sweden, and basically what he did is he used, you can see it on the screen now, this algorithm, which is able to detect a face and put a bunch of points on there very quickly. And what he used it for was like swapping faces. As you can see here. When I originally tried out his program and I fooled around with it, I did some face swapping of my own. I thought, how can this be applied to other things? And that's when I came up with this idea for this program to detect a few different emotions. It's pretty simple. Basically, I started out thinking like, what emotions do I want to detect? I came up with just like kind of like 5 things, just like kind of like a plain no expression emotion, surprise, happy, sad, angry, just some basic ones that I knew would be pretty easy to formulate when programming it. And basically what I did is, so OpenCV and the Python code, it's video capturing about 3 frames per second, mostly because of the speed of my computer. I'd imagine if it was on something faster, it'd run a lot quicker. But it's just cycling through my webcam video capture, and it's calculating basically. So it pins all those points on my face a couple times a second, and then it's calculating the distance between certain points on my face. So how I did this was I knew I was going to run into some problems if the face was up close to the camera or far back from the camera. So what I did first was create some functions to determine like the ratio between the length and width of the actual video. So it was 1280 by 720, and then maybe the height, the total height of the face was going to take up like 30% of the screen or something like that, and the width was like 22%. So once I got those ratios, I simply calculated if it's a surprise expression, their mouth is probably going to drop a little bit. What's the distance between like the upper and bottom lips, that kind of thing. For anger, normally you kind of furrow the brows a little bit. You get angry, you kind of dip your head a little bit. What's the distance between the top of the eyebrows there to the top of the eye? When you have an angry expression, you kind of like bring your eyebrows down closer to your eyes there. How do we calculate that? Basically, I just looked at the distance between those two in the pixels, and if it crossed that threshold on the screen, it would read angry expression. And pretty much the same with the other expressions as well. Between surprised, it was the mouth. Happy, it was how far out your lips went on screen. One of the problems I ran into with that actually is if somebody's not like smiling with their teeth shown, Some people smile with their eyes, the expression goes. If some people aren't showing their teeth, it might not read that they're smiling, and it'll actually say that they're sad looking. You look at the angry expression, like I said, that was the brows furrowed. The sad expression was basically if they kind of made like a frown, like if they pinched their lips together a little bit, it would read the sad expression. As I kind of made the joke earlier, like if you're kind of naturally sad looking, like I guess I was in the video there, it might take your no expression as actually a sad expression. And it really is kind of simple. Basically, once it detects that so there's certain distances between the the locations on your face, it'll just put on the screen surprised, happy, angry, sad expression or no expression. So I definitely could have done this program if I could have done emotion detection with machine learning. I certainly had a lot of practice with it, but I decided to go with this simple detection based on ratios of pixels and stuff like that because I wanted to try out this algorithm, kind of see how it worked.